There's an interesting story behind these unusual concrete shapes. Like a puzzle, they combine to become something more than a collection of individual parts. But that will happen far underground, beneath the bottom of the Fraser River. The finished product being manufactured by this crew will never be seen by the public. Nonetheless, these sections of precast concrete are destined to become an important piece of Metro Vancouver's water supply system as part of the Port Mann water supply tunnel.
For this project, we're manufacturing 1,000 ring segments. Each ring itself is made up of 6 different units, different segments. Each segment is 1 meter long. They're put together into the ring, which is, each ring is 1 meter long, and 1,000 rings make up the 1 kilometer tunnel.
The existing Port Mann water main is one of several key water supply links to municipalities south of the Fraser River. This new, larger water main will help ensure the continued reliable delivery of clean, safe drinking water to these municipalities and will more than double the capacity of the existing main. Here's how it works. The water supply tunnel is being constructed underground, beneath the Fraser River. A TBM, or tunnel boring machine, will dig its way north beneath the river, creating the tunnel. Along the way, the tunnel liner sections are installed to protect and support the steel pipe that will eventually carry the water. The liners are made in Richmond at the Armtec precast concrete plant. This crew has been working for about a year, manufacturing the 6,000 individual sections required to create the 1,000 ring segments that will line the 1 kilometer tunnel.
To produce the 1,000 ring segments, which are 6,000 units, it's going to take approximately 14 months. Generally, we produce 18 sections in a day, which comprises 3 rings. We do double cycle if schedule warrants, and we can turn over the forms twice a day to produce 36 ring segments if necessary.
It takes 6 specially shaped pieces to form each ring of the tunnel liner. Once underground, sections of steel pipe are inserted inside the liner. The weight of the earth and the groundwater above the tunnel is considerable. The thick liners are built to withstand the extreme pressure far below ground, protecting both tunnel workers and the water supply pipe that will be installed within it. Producing the 6 segments that make up 1 section of tunnel liner takes approximately 3 hours.
Form preparation is the first step. The forms are open. They are oiled with a bond-breaking material to keep the concrete from sticking into the steel form itself. From there, we make sure they're closed up properly with all the inserts in place. We take the final dimensions, do the quality checks, being a pre-pour sign-off. And then from there, after all of this is done and documented, we're ready to start pouring concrete. We bring the bucket of concrete over top of the mold itself, and there's an opening in the top of the mold. We pour the concrete in while using external vibrators to consolidate the concrete properly into the mold. After the mold is filled completely, there's a small amount of external vibration just to finish off the consolidation. And then after that, we screed that open area. Once the concrete has got a certain amount of set, so we can open the form without anything sloughing away, we open the back ends of the form. And from there, we screed everything to its final dimension and put the final finish on it.
Each batch of concrete is tested before the concrete is poured into the form to ensure it meets specifications. The concrete is a relatively dry mixture. An innovative feature is the use of steel reinforcing fiber rather than the traditional rebar cage. These tiny slivers of metal do the same job as traditional reinforcing steel, giving each segment additional strength that can't be achieved with just concrete alone. A crucial step is demolding, when the concrete segments are removed from the forms where they cured. A vacuum lift is used to make it possible to hoist the concrete liner with its smooth, curved surfaces. Each piece must be flipped 180 degrees and then stacked on a pallet for storage until it is needed at the job site. A total of 6,000 individual sections will be produced, creating the 1,001-meter wide rings which will line the 1-kilometer length of the water supply tunnel. The final manufacturing step is to glue the gaskets that will provide a seal between the sections of ring. Once installed, the space between the concrete rings and the inner steel pipe will be filled with cellular concrete.
McNally, Aecon, and Armtec have worked together before in the past, and on this project, right from the onset, we got together and partnered on it. And in pulling our expertise, it really helped in making this a successful project.
The project is expected to be completed at the end of 2015.